Hi everyone, meeting you again through this video education session is very interesting. Thank you. Let us discuss about linear regression in this video session. What is linear regression? Linear regression is one of the learning models in machine learning. So before we are going to learn about linear regression, let us touch about machine learning and what different types of machine learning available and how where the linear regression fits with the machine learning, all those things. Then we will go to use Python to code our linear regression model, how to get it one. So the next thing is we are going to talk about machine learning. So when we are talking about machine learning, what is machine learning? We are giving the historical data to any one of the models in machine learning. Then it would give it learns from our data and it gives a response that can be used for our business. So when we are talking about machine learning, there are two kinds of machine learning. One is called supervised and another one is called unsupervised. When we are talking about supervised, what is it supervised? We are going to supervise the model. That is the reason we are saying it is supervised. Supervising means we are guiding the algorithm. How we can guide the algorithm is we are giving not only the features of the data, we can also give the labels. Labels is what we are going to determine through this model. So that is the way we are guiding the model. That is the reason it is called supervised. For example, we have got a training a big data set. Let us take an example of the customers, e-commerce customers. That is, we have got a e-commerce site where the customers are coming and buying or getting our services for which they are paying. So we have collected the data for them. This is called historical data. Historical data means observations of these customers. So every customer data is called one observation we have collected. So these customers are coming and buying the data. So we have collected data saying that how long they are member with our site, what is the buying frequency of their visiting our site, and any other demographic data we have collected, their age, income, all those things. Along with, we are also collecting the yearly spent of this every customer. Yearly spent is the variable we are going to determine. That is what our interesting. That is our objective, to find out if these customers are having these kind of features, how much they are going to spend in our site by buying our product or availing our service. So here the data set we have got all the features along with yearly spent also. So this data set can be split into two. One is training data set and another one is testing data set. So we are giving this training data set to our model along with the yearly spent label, that is called a label. So now our model learns our input features and how these are all related with our output feature, that is called a yearly spent. So it understands, it finds out what is a underlying relationship, all these variables. So it can learn from our training data set. So here we are guiding the model by giving the labels also, so that can easily learn from our data. That is the reason it is called supervised learning. Once the model learns from our training data set, then we can give the testing data set. Now we are not giving the labels, only the input features we are giving to the model, so it can predict the values. Because we have already got the actual values of the tested data, we can compare our actual values with the predicted values, by which the performance of the model can be evaluated. Once the performance is good, then we can use the model. Otherwise, we can fine tune the model to get proper accuracy or the proper performance of the model. Till then, we are using the training data to train the supervised model. So because we are guiding the model or the algorithm, these models are called supervised learning, and the supervised learning are further divided into classification and regression. For example, in our example we have just discussed the price of the house or the yearly spent by the customer. That is a continuous variable. Continuous variable means it can hold any numerical value. It can be 0 to infinity, any numerical value. So continuous variable. If the output of the model is a continuous variable like this, then that is called a regression. On the other hand, if our output variable may contain categorical values like gender contains male or female, or something no go or no go, or high medium value. These are all some kind of categorical variables. If our model is going to determine the value of categorical variables, then those models are classifications. So in supervised models, if the output is a continuous numerical value, then it is called regression. If the output is a categorical variable like gender or go or no, then it is called a classification. And now let us come to our next difference of the machine learning, that is unsupervised. Here also we are giving the historical data, but we are not giving any specific information about the data. That is, we are not giving any labor or anything. The reason is we don't know anything about the data. We are just collected the data and that will be given to the model. This model can be what the model will do is it is going to determine the underlying structure. For example, one of the models in unsupervised is called clustering. In clustering, what will be done is we give a big data set to the clustering model. Then the clustering model gives a few subgroups of the data. Those are called clusters. Subgroups of data, those are called clusters. Means we can then identify every cluster by the values of the features in that cluster, and we can name it. For example, we have got marketing data from the marketing team. Then we give this big data set to the clustering model. What the clustering model will do is it goes underlying structure and process the data and gives a number of groups. Groups are nothing but clusters. Then we go and find out, we have to go through every cluster to name it. For example, one cluster contains the customers are in the age of in range 35 years to 45 years, and their income, the annual income is between 5 lakhs to 6 lakhs, and they are from suburban area. Then we can name it as middle-aged, mid-income suburban people. Likewise, we can go through every cluster and find out the values of the features, and we can name it for future reference. Once we can name it and clusters are properly identified, we can give this result to the marketing team. They can use these segments of people for their marketing strategy. This is the way the unsupervised learning can be used. So I will go again one more thing. The machine learning is divided into two learnings. One is supervised learning and another one is unsupervised learning. In supervised learnings, we gave the model with labels so that it can easily learn our data, and based on the learning it could give the response. Again, the supervised learning can be divided into two, that is a regression and a classification. If the output of the model is a continuous numerical variable, then that is called a regression. If the output of the model is a categorical variable, then that is called classifications. Then the another one category of machine learning is unsupervised. Here we are giving the historical data, but we are not giving any other information, any specific information about the data, so that the model can undergoes the model can find out the underlying structures, and it gives some kind of output. From the output we can learn something. Based on our learning on the output, we can name the clusters. So this is the way the unsupervised learning is being used. Now we are moving to regression analysis. The regression learning is one of the learnings coming under the machine learning. It is under the category of supervised learning. What we do is in regression is we are giving the training data with the labels, and the regression model tries to find out the relationship among the variables. Among the variables means when we are giving a number of features, then one of the features would be identified as a output variable, and the remaining features can be identified as input variables. Then the regression model will do what it will do is it is trying to find the relationship of output variable with each and every independent variables. For example, we can give a data set where the output variable is the salary of the employee, and the input variables are experience, level of education, role, city they work in, and so on, the department or whatever it is, and so on. There are a number of input features. Here the salary of the employee is the output variable, that is what we expect from the model. Then the remaining variables are input variables. Those are the experiences, level of education, role, city. These are all input variables. In another one example, the output variable we can consider the price of house. Then the input variables are the location where the house is, the square feet area, number of bedrooms, and the distances to the city. These are all the information we can give as input to the variables. So here the output is price of the houses, and the input variables are the remaining variables. So the output variable of the regression model is called a dependent variable. This is very important. In the first example we say the salary of the employee. In the second example we say the price of house. These are all the output variables. These output variables are called dependent variables. Why we are saying dependent variable is the regression model will find the relationship of output variables with each and every input variables. So its value depends on the value of all the input features. That is the reason the output variable of the regression model is called a dependent variable. At the same time, the input variables are called the independent variables. Why these are all called independent variables is we assume in regression model that each and every independent variable has no relationship with other independent variables. For example, in the second example, the square feet area is one of the input variables. So what our assumption is, the square feet area doesn't have any relationship with the number of bedrooms or the location or the quality of material we are using. So it doesn't have any relationship with any one of the input variables. Likewise, the number of bedrooms has no relationship with the other input variables. That is the reason these variables are called independent variables. So the output variable is called dependent variable because it depends on all other input variables. At the same time, the input variables are called independent variables because there is no relationship among the input variables. So the regression problem have one continuous numerical dependent variable. This we have already discussed that the regression problem have one continuous numerical dependent variable. If it is a categorical variable, then that will be called classifications. But in regression, the output should be a continuous numerical variable. The independent variables can be at the same time can be anything. It can be continuous, or one of the input variables may be discrete, and another one of the input variables can be categorical data. So the input variables can be any type. It may be continuous or discrete or even categorical data in regression model. The next thing is when implementing linear regression of some dependent variables y on the set of independent variable x equal to x suffix 1 up to x suffix r, where r is the number of predictors. that we are saying that, let us assume we can assign y as the output variable, and the input variables are assigned with a series of x, that is x suffix 1, x suffix 2, x suffix 3 up to x suffix r, where r is the number of input predictors, that is input variables. Here then the linear relationship between y and x is this formula: y equal to beta suffix 0 plus beta suffix 1 into x suffix 1 plus beta suffix 2 into x suffix 2 up to beta suffix r x suffix r plus epsilon, that is error. So here the beta suffix 0 is called the intercept, that we are going to discuss later, and the epsilon is the error, that is that also we are going to discuss later. Now we can focus on this beta suffix 1, beta suffix 2 up to beta suffix r. What are these variables? These variables are called regression coefficients. These coefficients denotes how the input variable is related with the output variable. In other words, how the output variable depends on input variable. Those can be identified by the regression coefficients, that are beta suffix 1 to beta suffix r. This function should capture the dependency between the inputs and outputs sufficiently well. Actually, the dependencies, that is the regression coefficients, should be exactly found out. Then only the performance of the model would be at high level. So the dependencies between the inputs and outputs should be properly estimated by the model. Then only the model can be at a high level performance. So in other words, the predicted value should be as close as possible to the actual values, so that the performance of our model will be really very good. So in the performance, when we are talking about performance, when we discussed about supervised learning, we already said that a training set of data will be used to train the model, and once the model is trained, then we are using the testing data to evaluate the model. So here we are going to evaluate the performance of the model. And before coming to a performance model, we can talk about the error. In the previous slide, I said there is epsilon, that is error. Here we are going to talk about the error. The error is nothing but residuals. What is residuals? In testing data, we are giving the data without label, and the model predicts the values. And at the same time, we have got the original actual values also. So the difference between the actual values and the predicted value is called the residual. That is the error. And the performance, one of the performance measures is called SSR, sum of squared residuals for all observations, that is I equal to 1 to n, where n is the number of observations. So here we are squaring the residuals. The reason is we are very much interested in the magnitude, not about the direction. That is the residual. Residual is nothing but the distance between the predicted value and actual value. So that distance is very much important, not about the direction. What I am saying is distance is magnitude. Direction is whether it is negative or positive. We are not interested to find to note whether it is negative or positive when we are considering the performance. So that is the reason we are square the residuals. For example, the -2 as well as the +2, when we are squaring these two, we will get the positive value 4. So here the value is important, not the direction. That's the reason we square the residuals, and the SSR is the sum of squared residuals of all the observations. So the SSR equation is SSR equal to the sum of squared residuals of all the observations. That is the equation by which we can find out the performance of the model. Another one performance measure is called R square. It is the coefficient of determination that tells the amount of variation in y that can be explained by the dependence on x. And the r square value should be in the range of 0 to 1. So if the larger r square indicates a better fit, that is, the performance of the model is very good. But in other words, if the r square value is very closer to 1, then the model would be better. That is what our aim of getting the model. And the value of if the value r squared equal to 1, then the corresponding SS are equal to 0. This is the perfect model. We are trying to get a perfect model. If it is not possible, then we should head to r square as closer as possible to the value 1. So that is our objective of developing the model. If the model is r squared is not that much closer to 1, then we have to train the model with some training data, the modified training data. Then we need to get the r square very closer to. Simple linear regression. In simple linear regression, we consider only one input variable to predict the value of output variable. For in our house price example, if we are considering only the number of bedrooms to predict the value of house price, then the model we are using for regression is called the simple linear regression. If we are using more than one variable to predict the output value, then that regression model is called a multilinear regression. In this graphical representation, we are considering only the simple linear regression for the simplicity to understand how to draw a regression line. So in this graphical representation, the green circles are represented in x-axis. Those values are the actual values, actual response, and the red rectangles are represented in y-axis. Those values are the predicted values. And the line between, the distance between predicted value and the actual values are represented by a gray line. Those are residuals. When we draw a line among the predicted values, that is red rectangles, then that line is called a regression line. And the formula for that line is beta suffix 0 plus beta suffix 1 into x suffix 1. That is a regression line. That is the formula for the regression line. It is a simple linear regression. Hence, we consider only one x value. And what is beta suffix 0? We already mentioned, that is the intercept. The intercept is when the value of, in simple linear regression, when the value of x is 0, then the value of y is called intercept. In other words, if the value of x is 0 and where the regression line meets at y is called the intercept. In case of multilinear regression, the value of all the input variables is 0, then the value of y is equal to intercept. That intercept is used to calculate the regression value or the regression line. Now we are moving to the coding part. Here we are going to use Python to code a regression model, for which the e-commerce customer data is used. In e-commerce customer data, our output variable for the regression model is yearly amount spent. We have a column that contains the yearly amount spent by the customers. When we use this regression model to predict the yearly amount spent, by which the business understand how much a customer is going to spend yearly, then they are in a position to come out with a proper plan of how the customer personalized offers or loyalty membership can be defined for that particular customer. In this way, this regression model is used for the business.